Hello, and welcome to our May webinar, FileCatalyst May webinar about 10 gig file transfers. Today I have with me Christian Charette, which is going to show us a really cool 10 gig transfers in action, and that's my special guest for the month. So just to cover up who we are, I am John Tkachevsky. I am the president and co-founder of FileCatalyst, Unlimited Software, the makers of FileCatalyst products. You can look at our blog for some articles about file transfer and other high-tech related information. And Christian is our director of software development. He is the main project lead on the 10 gig file transfer software.
How's it going, everyone?
So just to give you a quick overview what we're going to do, we're going to cover which product we're really talking here, because we have, between all the products and at FileCatalyst, we have, direct, webmail, workflow, and central. We're going to be mostly concentrated on FileCatalyst Direct today, and the products of Hot Folder and the FileCatalyst Direct server. We're going to give you a quick refresher why TCP doesn't work on fat pipes, and we're going to show you what we use, what type of hardware we use to do the 10 gig transfers, and then we're going to watch some really cool demos here by Christian. So if you have any questions, feel free to type them into the GoToWebinar questions box that you should be able to see on your screen, and we will get to them at the end of the presentation. So just to give you an idea what FileCatalyst Direct is, it's our main point-to-point product for doing transfers, point-to-point file transfers. It is a client-server architecture, so it's you have a server where you have your central repository of data, and then you have different client applications that can connect to it and either upload or download files from that repository. We have a number of clients, including like a command line or APIs or Java applets. Today we're going to mostly be talking about the hot folder and the server application to do the transfers. Some of the other client applications we provide is also the Express, FileCatalyst Express, which looks a little bit more like a FileZilla interface where you can do an on-demand quick file transfers, ad hoc transfers, instead of configuring something ahead of time. FileCatalyst, most of our products have been primarily written in Java, although we do have now ports also in C++ and as well as in the iOS port. So that allows us to run on a variety of servers and hardware configurations. Our protocol has been built from the ground up by our own team. We don't use any open source products for file transfer, so this is all our own technology we've built from ground up, and we have an excellent congestion control, meaning there's no configuration required. It just out of the box works really well and will speed up or slow down to allow other traffic through. Besides that, we also have a very good bandwidth scheduling, very flexible bandwidth scheduling if you want to schedule certain transfers to be more aggressive at nighttime and take it easy during the day when you have other business applications running. So just to give you a little bit of background here, why 10 gigabits and why now, and why it didn't happen 2 years ago? Well, there's certain technical challenges we had, which we had to resolve at first. So we needed the appropriate hardware to be able to go as fast as 10 gigabits is. The 10 gigabit technology is really fast. A Blu-ray disc can be sent in under 30 seconds. Pretty much anywhere in the world. There's no worry about any kind of network impairments. So if you want to send this Blu-ray disc from LA to Sydney, Australia, no problem. If you want to go to Rio from New York, no problem. The network never gets affected. Our protocol never gets affected by the network. Another reason why now is the time to talk about 10 gigabits is that 10 gigabit links, private links, are dropping in price. We've heard reports now that you can get a 10 gigabit dedicated line for about $10,000 a month from between US and the UK. So the cost is starting to come down to the point where enterprises and businesses, medium businesses, can take advantage of that and really speed up their workflow, their production workflow. Another reason is that on the residential side of things, connectivity is also improving a lot. Fiber connectivity to the residential consumers is starting to be the norm in a lot of countries. High-speed links, we've seen links right now ranging up to 1 gigabit to residential homes. So what that means is that, once again, on the server side, you need the appropriate connectivity, so you can properly serve those very fast links on the consumer side. So I'm going to just pass on my I'm going to move the conversation to Christian, which is going to give us a quick refresher about TCP and why it cannot go this fast on these really fat pipes. So Christian.
All right. So here we go. What you've got. So I'm not going to go and show you a demo of TCP, unless you guys absolutely want to see TCP running slow on faster connections. What I've done is I pulled a few slides from a presentation we had done at Photonics North. This is a show we did in Montreal. And what we did is we did a lot of analysis to figure out exactly how fast different protocols go, especially when it comes to TCP, based in various network conditions. What you're looking at here is a 100 megabit link, which a lot of businesses have. And we've decided to do a couple of things. On the link, what we did is we tried to transfer data out as fast as we could with different latencies. So to give you an idea, a 10 millisecond latency could be a couple of buildings in a larger corporate campus. 25 to 50 milliseconds, you're kind of looking at regional transfers. 75 milliseconds would be somewhere between like New York and LA, for example. 150 is from North America to certain parts of Europe, etc. And what this graph shows you is even at 100 megabits, TCP starts to slow down. And it slows down especially when you start having packet loss. What you can notice is even with a small amount of packet loss, all of a sudden the transfer stop going fast. So you're looking at 30 megabits out of a 100 megabit link if you're trying to cross the continental U.S. Using TCP. And as soon as you start having links that go underseas, you inevitably get packet loss on a link. It is rare that you're going to have an absolutely clean link. And so TCP really starts to fall apart. So this is what it's looking at, 100 megabits. It's not looking so bad. A lot of companies could say, well, I could probably do with using only 30% for one file transfer on my link, and I'm still utilizing a good chunk of it. Skip over to the next one. There we go. Now we're looking at a gigabit. So all of a sudden now you're once again seeing FTP start to flounder. It's really having a difficult time, even on a clean link. So if you're looking at that orange one that starts off pretty good, but then starts to tank out about 10 to 25 milliseconds. What you're looking at, even on a clean link, trying to cross the U.S. on a full gigabit link, you're not going to be able to do it. And for the most part, what we've seen in a lot of customers is, in fact, it's never a clean link. It's actually a lot slower than that. And what you'll generally get from LA to New York, for example, is you'll get 5 to 10 megabits going across the country. And this is just a problem with the underlying TCP protocol. Because we're based on UDP, we can overcome them.
So Christian, if I was really smart, I would say, why can't I just tweak the TCP window size? I'll probably, can maximize my bandwidth that way.
Yeah, you can get a little bit. It's kind of like putting a small supercharger inside your car. You'll get a little bit of a speed boost at first, especially on a clean link. But TCP itself still falls apart as soon as you start getting even a minute amount of packet loss. The protocol just stalls. And so what you're going to get is, even with very, very large window sizes, TCP will come to a grinding halt awfully fast. And then you'll be scratching your head just asking your network guys what's going on, how come my link isn't getting my data fast enough. And your network guys are probably doing their work. It's the protocol.
So just to give you an example here, here's the light blue line here. You can see that's the 0.1 packet loss at 100 milliseconds. You're using about, what, 10 megabits or 20 megabits of the 1 gig link?
Yeah, something like that.
If you tweaked your window size and you improve this tenfold, you would be looking at 100 megabits maybe.
At the most. You know what, probably
most.
Even less. You're probably going from about 10 megabits to about 20, 25 megabits. The minute you start having packet loss, the protocol kind of stalls. It doesn't work. And I mean, it gets even worse. So if you go to the next slide, the faster speeds, essentially TCP doesn't even come out to play. If you look at over here, I mean, as soon as you start getting a little bit of a packet loss, I mean, you just cannot transfer using TCP over high-speed links. You need some other protocol. And so ours is based on UDP, where we do all the error correction and congestion control in the application layer rather than letting the protocol handle it. And so what happens is by doing that, we've actually improved upon what TCP does, and we can send that at full line speed despite having latency and packet loss. So the 10 gigabit research project actually started 2 years ago now, and started in May 2011. It took us about 6 months to complete, and the first time we actually released it out to the public was in November 2011. So we've been on the ball for quite some time with this. We've got a year and a half of successful deployments going out, ranging anywhere between 2 to 10 gigabits. Not everybody has a 10 gigabit connection, but we'll do anywhere from 2 to 10 gigabits in the field without a problem. And as a testament to our the quality of our product, we were actually picked up by a PhD candidate in Germany. His advisor is actually the ex-CEO of Tixel, so it's a competitor of ours. He's, after letting go of the company, he's back in the academic world, and he decided to go in, pick up software from a whole bunch of different companies who manage file transfers like ourselves. Did a lot of evaluation. I mean, I spent some time with him last summer, and they recently published a paper about the different solutions out there, and you can click on the link. I guess we'll be posting this somewhere up on our website at one point. I think we even have it up on our blog. And the results, of course, were that far and away, FileCatalyst provided the most stable transfers at 10 gigabits, regardless of the network conditions you threw at it.
What's important also to say is that our 10 gigabit technology is built in right into our FileCatalyst Direct product. So it's not a special ultra-fast file transfer product. It's not a different product that you have to buy to get the fast file transfer. It's just part of our core FileCatalyst Direct technology.
Yeah. So what are we going to be doing for this demo? Well, what we're going to do is I've got a couple of machines set up. One of them is going to be running our hot folder. So it's a hot folder is one of our client softwares. It's a scheduler, kind of like a cron job with a very nice GUI. It allows you to schedule transfers to either upload or download them from the server. On the other machine, I have a FileCatalyst server. So this is the latest build available up on our website. Each machine is circa 2011. So we've tested with both Intel Westmere series chips. These came out a couple of years ago. In fact, that's what's going to be in the systems over here. But we've also tested with AMD Opterons. They all work very, very well. And so in this case here, each machine has dual Xeons. I've got 40, well, I think the next slide's kind of show it. I've got 48 gigs of RAM, 36 reserved for RAMFS, so a RAM drive. So the actual application and the OS is below 12 gigabytes for both. Now, I wanted to kind of stress this out. So in the test we're doing, I'm going to be reading data from RAM drive and writing data to RAM drive. And the reason is I want to remove the disks. For this demo, I want to remove disks as part of the equation. The big reason is all of our customers who come to us, they all have different disk solutions. Even if I was to go out and pick one, the first thing you guys would turn around and say, well, that doesn't exactly match my disk configuration. So what I wanted to show you was from a pure transfer component, here's what we can do. And if your disk can handle the speeds, our software can write. And it can actually do the work.
So our goal is really not to show off how fast our storage is, which I'm sure you can go and contact your storage vendor and they'll show you a really cool demo of very fast storage. Our goal is here to show you really the WAN file transfer at 10 gigs, not the storage. And another thing is important to say is that none of the hardware used here is very expensive. It's all fairly common off-the-shelf hardware that's been around on the market for the last 2 years.
Right.
There's no experimental chips or anything like that involved.
No, very common hardware available for the last 2 years. And I know because we've had these machines for 2 years. So what happens is in our test, we're going to use a WAN emulator. And what happens is this is available from Apposite Technologies. And so what this does is it actually controls the link speed. You can enter in packet loss, link latencies, and whatever. So this was going to go in and actually simulate our network for us. It's a wonderful product. If you guys have the chance to go and pick it up and you guys are in this kind of a field, it's a great little tool to use. And so that's what we're going to use in our demo. Can we just show it up really quick?
The interface?
Yeah, I'll just grab the, oh, we have to go in the other one, eh?
You have to drag it.
Is it this one here? Okay, hold on a second. So there's our link trippy right now. So it's a nice little box that sits between the two fiber cards. And what happens is on the link trippy, we can go in and specify whatever we want as a configuration for our network. So in this case, what I've got right now is kind of mimics a link between New York and LA. So I've got about 60 milliseconds, 30 on each side between the two, and I've got a small packet loss of 0.1% configured on the link. And so, let me see here, what's the next slide? So what we're going to see is, I'm going to start off, the first demo I'm going to show you is just a static file transfer. So I'm going to grab a single file and move it from point A to point B. The file is 30 gigs in size, so it's slightly larger than your average Blu-ray disc. So a lot of media companies, they move these ISOs, these Blu-ray discs around, especially nearing post-production era. What happens is, I just want to show you guys just how fast I can actually transfer these things back and forth.
And it's another thing that is important when you're looking at file transfer solutions, to be able to find a solution that can maximize your bandwidth on a single file, sending basically one single file thread as fast as possible, and also to be able to maximize your bandwidth sending multiple files all at once. Obviously, the second problem is easier to achieve than the first one, but we just want to stress here that we can do both, and it really just depends of what your needs are for our solution, for our technology.
Yeah. So the first one is going to be one large file going from A to B. The second test, what I want to do is, we've been approached by a lot of companies recently. What they have in place is they have a live camera, high definition, sometimes 4K cameras, pumping out all of this data. They save it to a set of disks, and what they want to do is they want to move their data as it's coming in from the camera or coming off the transcoders. They want to move the data very fast in real time from the local disks off to a central distribution area where I guess they take it, archive it, and then work on the post-production. And so what I'm going to do is I'll create, I have a little script that I'm going to run. I'm going to start creating just these large, I've got 5 files. I'm going to create 5 6 gigabyte files. And I'm going to show you what we call progressive transfers. So the hot folder will literally pick up the files as they are, start transferring them, and as you add to the file, you're going to actually see that the application kind of looks at the file system, realizes that the file is growing, and it's trying to chase the tail. So it's constantly going to update back and forth the rest of the file as it comes in all the way until the file gets completed. And so this is really, really great for companies who, once again, have this live streaming data coming in, being written to disk, and they want to push it off to a remote site right away. So I'll kind of show that as a really quick demo as well.
Sometimes in the industry we also call that chasing the tail. So the file transfer is always trying to chase the end of file, which is continuously growing. So chasing the tail, or sometimes it's called progressive, as you mentioned.
So what I've got, my link tree set up. So I've got about 60 milliseconds and 0.1% packet loss. And let me go see if I can actually get.
The other configurations are there just as a reference. So if you try to replicate this in your own lab, you see what we've used here.
So let me see if I can bring up all my windows now. So the machines I'm working off is it's a couple of Ubuntu machines. These are set up in Linux, but like I said, it will work on Windows. It will work on Mac. So I just wanted, so the sender is going to be on the left side. The receiver is going to be on the right. So on the right is the server. And I just want to make sure that if I run my ping command, That's not working at all. What do I got wrong? Do I have to do a sudo? Ping-i. These demos. There we go. So I've got my pings happening here. Let me add the sudo onto there. There we go. Does this look right? This looks right. Oh, I've got the wrong address. 59, I'm pinging myself. There we go. So now I've got the ping set up so you can see from each of the machines I've got some latency happening. And I can control this once again. If I go into the connection and let's just increase it just for fun. Let's say instead I'm going to send it from, instead of going from LA to New York, I'm going to send it New York to London. Is that about 120 milliseconds?
That's about right.
So as soon as I update that, let's go back to my little machines there. There you go, and you can see that the machines appropriately have recognized that, hey, I've got more latency. I've got 120 milliseconds worth of latency. So from my sender, let me just make sure I've got the file set up. So du. So I've got a single file. Just make sure. So this is going to be, so I've got a single 30 gig file set up on one side. And let me bring up my hot folder and my server. So my server's over here. My hot folder is here. If you guys want at a later time, I think we've got some webinars already.
We've got some webinars covering hot folder and server products. Just go to our webpage and you can see the introductions to those products.
Yeah. So what I'm going to do is just, so I've already got this, configured, ready to go. I've got a task set up just to transfer that large file. So let me just kind of bring it up. And as you start to transfer, so now you can see it's going to pick up the file, and away we go. So what's happening is on 120 millisecond latency, and you can see the RTT kind of pinging up and down. It does this as the network gets saturated. But you can see that I'm transferring full speed. I'm transferring 10 gigabits the whole way through. You can also see it on the, let me go to the netropy here. There we go. Nice, smooth, 10 gigabit transfers. This is a network condition that you'd get from New York to, London or to Berlin. 120 second latency.
Wow, and we're done. That was 30 seconds. 30 seconds for a 30 gig file.
Yeah, these things don't take time at the speeds.
It was really fast. Can you do it again?
I can do it again. I can do it all day. I have a lot of fun doing this. Let's just have some fun. I'm just going to increase the amount of packet loss I get. I'm going to multiply it by a little bit. So this is, I'm getting a 0.5% packet loss, which is quite a bit actually. 0.5% packet loss, you've got a pretty dirty line, even if you're going underseas. For just about every other protocol you'd get on the market, it'll flounder. It will not work. You're going to see significant slowdowns. But this is FileCatalyst working at its best. And what you should be seeing is the exact same thing. It'll transfer slightly slower because you've now got closer to 1% packet loss, but I should be hitting the full 10 gigabits. There we go. So I am transferring, with 0.5% packet loss, 120 milliseconds, and you can see it. See the packet loss, it reflects it in the application. But I'm transferring at full 10 gigabit speeds. This is absolutely remarkable.
Very cool.
Yeah. And you can see it. So if you go once again on the netropy, just beautiful transfers the whole way through. Goes up, goes down. And by the way, this is with congestion control. So if there was other traffic and there was a contention, you could either set the aggressor. So our congestion control is very flexible. You can set it so it plays nice. So when it detects other traffic, it tends to slow down fast. Or you can set it so that it's very aggressive. So if there's other TCP traffic on your line, it'll try to push it out. Essentially, it will react, but very slowly to other traffic. And so, but this is with congestion control turned on. It is able to push that data all the way through. So we have that. Like if we go, let me do it. Okay, let me stop the pings because there's no point in having the pings. I have another little script set up here And what I'm doing is I'm just having a look on both sides of the application. So that's the sender. See if I have it. And this is on the receiver. So I have the 30 gig file set up. What I can do is I can actually just clear that file off on the receiver. Sudo. I did the watch, didn't I? Silly me. So I'm just going to delete the file. I should just do this. And no more sudo. Okay, so let me just do it one last time once again. So starting the transfer, and then you can see on the receiving side, you can see the data kind of just flowing at a really nice rate. You want to see the progressive?
Yes. So let's see the second use case you've prepared for us, which is the progressive transfers or the chasing the tail scenario.
Yeah, which one is this one here?
Mm-hmm.
Okay. So the I don't have. Well, the other scenario I have, once again, I think I had it up here somewhere, didn't I? Oh, I run it. I have lost it.
That's
there we
okay.
go.
You can.
It's right over here.
Commands.
So
yeah.
The second one here is what I'm going to do is I'm going to create these 5 files, and then we'll actually see it kind of running all at the same time. So let me. Is there a way to minimize this?
No.
Oh, silly Windows. So I'm much more comfortable on the Unix environment. So what I'm going to do for that, let me just kind of clear out the RAM drive on both sides. And that's gone. So what I've got is I've got a small script here. And what this script does is it'll create the 5 files at the speeds I specify. So I'm going to say I want to create it at 750 megabits. So we'll create 7 files, each one running at 750 megabits, which means I'm writing at approximately 3 gigabits a second or so. And you can actually see the file growing over here. Okay, so we'll let that kind of go up for a little bit. Let's grab the hot folder again. And what I can do is if I grab these tasks over here, and I say execute. Is now not a good time?
Go.
So we can actually grab one of these and just kind of have a look. So what the file is going to do, or what the hot folder is going to do, is it's grabbing the file. It's going to transfer it. So when it started the transfer, it had about 2 gigs or so worth of data on it. And it's going to start by transferring that 2 gigs of data, and then it checks. Oh, local file has increased in size. Let me transfer the next gig over, because that's what it has. And it keeps kind of going back and forth, all the way up until it recognizes, and when the 5 files actually reach 6 gigs, it'll actually stop.
And you can see here the progress bar. Can you just move the mouse over the progress bar?
Yeah.
You can see the progress bar never quite going to the end. So it looks like it's chasing that tail.
Yeah.
And that's what we mean by chasing the tail in the file transfer world. You can see it's almost there, but the file grew again, and therefore it's done until the files finish growing, and then you can see all the files arriving intact. Yeah. So let's see on the link tree how this traffic looks like.
So on the link tree, so what happens is, so remember the file growth, I had set up these tasks. I was actually creating the files at 3, almost 4 gigabits a second, but I'm transferring at 10. And I mean, I wanted to do this because what I wanted to show essentially is a transfer speed going faster than the actual data writing. Because honestly, when you're looking at 10 gigabit transfers and you're looking at high-speed video cameras, often, funny enough, at 10 gigabits, the transfer speed is faster than the cameras dumping the data in. But the software picks up those files without too much of a problem. And I mean, now that you've got 5 static files, what I can do is I can actually just kind of relaunch them really fast. I can close these off. So if I just grab these and I say execute, well, now I've got 5 static files. So now you'll get exactly what you expected out of the transfer, and what you should see is a nice, beautiful line transferring at full 10 gigabits. So this is actually an easier scenario. Transferring multiple files is a lot easier than transferring one file. One file at 10 gigabits was the most difficult part of the challenge for us, and it's something I know that our competitors haven't quite managed to get a grasp on. So that's something we're very proud of. But you know, here we go, transferring all the files, boom. So if you guys had a high-speed video around the world and you needed to get it from point A to point B, as long as you've got the network for it, this is the software that can be used in order to transfer it.
All right.
All right.
Well, thank you very much, Christian.
So we did good. We did it in 30 minutes. Are there any questions from anyone?
Previous. So let me so we finished our demos. Just want to remind you about some upcoming events where we're going to be present. We're going to be in New York City tomorrow, actually. Chris Bailey, our CEO, is going to be on a panel. We're also going to have a stand at Broadcast Asia in Singapore in a couple of weeks. And then we're off to Amsterdam, then New York City, and then to India for Broadcast India. So these are some of our events. We also have usually user forums planned around these events, so stand by to find out the details on these user forums. We usually try to do it just right around one of those exhibit events. And of course, don't forget our monthly webinars. So let me just take a look at quickly at questions. I don't see any questions from this session, so
I'm hoping you guys all had fun. I certainly did. And then if you guys have any other questions, feel free to contact us or the sales team, and we'll take it from there, I guess.
Yeah. Thank you very much. Thank you, Christian.
Thanks. Bye.